given me the opportunity to work with lots of different types of technology and explore some stuff that I maybe only dabbled in at university or before.
SSW is a company that makes enterprise software solutions, and that's what we do. We build software for clients on demand. We build bespoke solutions using the latest technology and the latest best practices.
I've been involved in the development of some mining software, been involved in the development of software for a legal firm, and everything in between there. Even in just under 2 years, I've been working across so many different projects.
We play as hard as we work. You know, it's just a really great place to come into, and I always look forward to coming to work.
So since I've been working here, I've really been pushed, and that's what I wanted. You come to a place where you're working with a team of just absolute weapons. We've got the best in the business here, and that's an exciting place to be.
The guys are very passionate about doing things right the first time. We share our best practices with the community and with our clients and with others. Using conferences, we speak at events, and also we have the SSW rules, which is a huge archive of the best way to do everything.
The management here is totally approachable. So if you have a better way of doing it, or you know of a better method, then everything is up for discussion. As an example, say authentication. So a lot of the guys are building authentication into their apps, and they've been through many different ways of doing that. So generally what ends up happening or coming from that is a discussion around what's the best way of doing it. And we come to a decision based on industry best practice, as well as our own experiences on what the best method and approach is. And that then turns into a rule that we have on our rules.ssw.com.au website.
What really defines this company and make it work is the fact that we have people that are able to share their knowledge and solve complex problems together. It's a wide variety of different clients, different structures, different sizes, different industries, and different technologies as well.
The world we live in now is just so many light years above the world that we were working with even 5 years ago. We get into lots of topics deeply, and it's fascinating how it all works and why it works. You know, we get paid to make fancy jigsaw puzzles.
Access granted.
Developing software is a unique opportunity to be creative and technical at the same time. It gives you the opportunity to solve problems. It gives you the opportunity to exercise and flex your mental muscles by solving problems and figuring things out, while also being creative.
You can feel that energy when you come into the office. There's a really good vibe and connection between everybody who works together here. It's really collaborative, and we even have the tools for doing that collaboration now as well through Microsoft Teams. We always try and team up in pairs where possible for client work. 2 heads are always better than 1.
I believe being a developer, a good developer, is writing good quality code. But being a great consultant, which we are at SSW, is half-half between technical skills and communication. That's what makes us different on the market. That's what gives us our edge, because we're capable of not only doing great work in terms of technical skills, but also bringing value and bringing our insight based on our experience, saying, oh, to solve this problem, I would recommend you going that way or this way. And bringing that value, that strategic value to a client, and being able to phrase it, not only having it in your head, but phrasing it to give them options.
And we make sure that people are communicating internally with each other in a way that is professional and succinct, and we make sure that that's the way that we communicate with our customers as well.
And I want to show you a few ways that make email more useful.
People that want to improve their communication through public speaking can do that through the conferences that we're involved in. They can do it through SSW TV.
You might actually not need to go native, guys.
We have a lot of videos that kind of help get your face out there, to get your name out there. We also have a really good social media presence. We have a great marketing team that takes care of that.
We are client-facing all the time. There's no way to work at SSW and just be behind the desk and not talk to anyone. Every day you have to communicate. So that brings communication as a core skill of what you become. And some people develop it a way further, like by doing public speaking. We have awesome speakers. I think NDC videos prove that. We have awesome tech tips and even conferences given by SSW people. I think we had like 6 or 7 this year, so that's pretty huge.
One of the exciting things about working here is we're always on the bleeding edge of technology. We're always trying to reach out to those new projects. What are other people doing? What's the next best thing? I think Adam being a Microsoft Regional Director really gives us a bit of an edge in that regard as well, because he usually knows what's in the pipeline before other people do.
We've had many younger guys come through SSW, and in a few short years, they've become absolutely amazing developers.
You can have guys with just a few years of experience and they're building software that's affecting tens of thousands of users with some guidance of the software architects. It just works. Like, it's amazing. You build something and you test it that you can enter an order, and then all of a sudden you can enter thousands of orders like in seconds. It's just incredible. We couldn't do that a few years ago.
We have a couple of different ways that we socialise. Every lunchtime, we're killing each other in board games, which is always good.
It's interesting because those games, are about psychology. That's very interesting. You learn a lot about people.
The most exciting thing that we do is obviously our company retreats. We go away for a weekend after doing a brainstorming session. On the Friday, we all work together as a group and work out, problems for the company itself. We always try and keep the activities a little bit different to make it a bit of fun.
It's just a great weekend all around.
People that come to work here want to be at that level of globally recognised expertise that some of the best guys at SSW are at. And even if you're not at that stage now, I think that a lot of people that come to work here are inspired by that.
A lot of clients come to us with maybe a general idea of what they want. And you can use your expertise and past experience to really inform their decisions and make sure that they're developing the best possible product. I really enjoy that part of it. I think that would be very satisfying for anyone who's been working on maintaining an old piece of software or maintaining an old system. If they could come and maybe work on some new greenfields projects and potentially influence the way that product comes out at the other end.
You can come up with cool designs, you can come up with new solutions, you can come up with elegant ways of solving problems that haven't really been done before, and plus you get to build something. And often the projects that we're engaged with, you get to build something that's going to make a difference.
People want more stuff automated, they want richer interfaces, they want bot interfaces. The architecture keeps expanding, the knowledge of Azure keeps growing. Like, I'm still learning. I'm still trying to get better. I'm still trying to make solutions quicker, more maintainable, cheaper, and there's a long way to go.
I feel like Adam's like true competitive personality only comes out on retreats. Like we go on a bushwalk, or we play tennis, or we go swimming, or we go go-karting, and all of a sudden he's just like, get out of the way!
Thank you very much for coming in, guys. I hope you all enjoyed your rides today, and I hope we see you all again, guys.
To SSW.
This month on SSW Tech News, the AI race reaches the real world with NVIDIA Cosmos. GitHub Actions are helping you secure your code. And level up your smart home with Google Home APIs going public. I'm Eve Kogan, let's get into it. Starting off as per usual these days with the latest update in the AI race. Google has released Gemini 2.0, and it could be the most powerful large language model yet, especially when it comes to its multimodal capabilities. Even though it's just an experimental preview, it's performing quite well when dealing with combined text, audio, and vision. It's also got a focus on AI agents, or agentic AI, as everyone's starting to call it. For example, Project Astra, which allows you to hold up your phone and the AI agent will help you interact with the world around you, tell you what you're seeing, help you read things, interpret them, even tell you where you left your glasses. And for developers, there's Jules, a new agent specifically for helping developers find and fix their bad code. Moving from large language models to small language models, Microsoft has just introduced 5.4, its newest small language model specializing in complex reasoning. So what is a small language model? It's an AI trained on a smaller data set, and because it's smaller, it's faster and it's usually requiring less compute. In this case, it specializes in maths problems. So if we look at the specific example of maths competition problems, we can see that Phi is performing better than all the major models, including Gemini and GPT. To be specific, it's solving problems just like these better. We can see it's fleshing it out and giving us quite a complex set of reasoning. And you can get on board and have a play about yourself because it is open source on Azure AI Foundry and Hugging Face. Over to some GitHub news. GitHub Actions is making it even easier to secure your code. Recent research has uncovered over 90 security flaws in more than 75 GitHub Action workflows. And they have devised some actions to help deal with common vulnerabilities. This is preventing being pwned, untrusted input, and how to trust your building blocks. Get on github.com to check out new tools like bash support and taint tracking. AI is reaching the real world with NVIDIA Cosmos. Cosmos is helping developers build tools for AI robots, cars, and other autonomous systems with built-in reasoning and decision-making capabilities. It's not a large language model, it is a world foundation model, and it's one of the first and most powerful of its kind. Basically, it's a software version of the physical world, where you can test and use robots and cars in the digital world rather than the physical world. It's got some built-in tools that are pretty cool. Let's have a look at some of them. We have video search, which allows coders to simplify video tagging and understanding spatial and temporal patterns. There's controllable 3D to real-life synthetic data. This allows for photorealistic videos that are precisely controlled by 3D scenes. There's also policy modeling, and this allows for developers to test risky real-world things or navigate complex simulations. Foresight is also known as predictive intelligence and enables systems to anticipate future scenarios and make smarter decisions. There's also multiverse simulation, which is about selecting paths for enhanced precision and reliability in complex environments. And I'm loving all these images that really illustrate all the different purposes we could be using this AI for in the real world. Some pretty well-known companies already using the tech include Neurorobotics and Uber. Basically, it means that devs are empowered to make AI for the real world cheaper and faster. And some more NVIDIA news, this time for the gamers. We have this very powerful new RTX 50 series. So the RTX 5070 is actually delivering the same performance as the RTX 4090. And that's at 1/3 of the price. So it's delivering these really high-end graphics at a much more affordable price. It's perfect for demanding tasks like gaming, AI development, and 3D rendering. And some good news for democratizing AI tools, we can see the GitHub Copilot is now free on Visual Studio. So that's just making these tools more accessible for developers and simplifying coding for everyone. So these tools, they're basically helping automate repetitive tasks, solve tough coding challenges, and save time, whether you're a beginner or an expert. Let us know, was price ever an issue for you? And if so, is this going to get you on board? Because now there's no excuse. Get using GitHub Copilot. And a small but important bit of news, .NET install domains are changing. Microsoft is shifting the installation domains from .nougat.org to microsoft.com. Make sure you update your configurations because you don't want any broken automation pipelines or project downtime. And some good news for devs who are Google Home owners. Google Home APIs are now in public beta for Android, giving developers tools to have a play around with things like their smart speakers, thermostats, lights, and plugs. And good news for iOS users, because that'll be coming in just a few months. And of course, Musk had to make it into the news cycle, this time with X launching Grok's iPhone app for US users. Before, you could access Grok inside the X app, formerly known as Twitter, but now it's its own app. That means it's competing directly with things like ChatGPT, Anthropic's Claude, Google Gemini, and Microsoft Copilot. Its point of differentiation? Allegedly, it's uncensored. If you're a US user, let us know in the comments how you're finding it. Is it weird or is it wonderful? Google has turned your Discover feed into an AI-generated podcast. So you know when you open the Google app, or maybe you open Chrome and it gives you some suggestions about things it thinks you might be interested in reading? Well, that's now been synthesized into a monologue read by an AI agent. You can control pace and volume and see whether you like it or not. It's kind of interesting over here, there's a story about matcha, and I wouldn't mind starting my day with a story like that. But unfortunately, I'm an Australian user, so I probably won't have that for a few more months. If you're in the US, give it a go. Tell us if it's interesting. And that's all for SSW Tech News this month. If you think we've missed any cracking stories, let us know in the comments. Next up, we have TJ Gokken, and he's talking to us about building HAL, creating multi-language AI-powered applications with Rust, Python, and Blazor. Over to you, TJ.
Everyone, how you doing? The other day, actually, I was building an application to, improve the performance of my computer, and something happened that really was shocking to me. But you know what? Instead of talking, let me just show it to you because I recorded it. Okay, after that dramatic entrance, let me just show you. I was actually intrigued, and I said, hey, what can I do to improve the performance of my computer? How many of us or of you know what the screen is? By show of hands? Yes, we all went through this, right? It's actually quite amazing to look at it. You can just spend hours looking at it, seeing what it's doing. And we went through this, and that gave me the idea of HAL, which is hardware assistant that learns. And when we were doing this, or when I was doing this, I said to myself, okay, what can I use to make this more interesting? And I wanted to use and harness the power of AI. So I said, okay, for something that works, I need to use Rust because that's the closest to the metal. And I need to get this information, the system information from my computer. But then I said, well, how can I get recommendations? The best way to get recommendations is using a framework called AutoGen. How many of you heard AutoGen? Okay, good. AutoGen is a multi-agent framework from Microsoft. So what it does is it fires up multiple agents, and they communicate with each other, and they try to collaborate and come up with a better solution for your problem. It's actually quite cool, and we're going to see this, how that works. And for AutoGen, though, I need to use Python, because Python is the AI or ML language, and that's basically the best way to access AutoGen. There is AutoGen.net if you want to use it in .NET, but I want it to be as close to the source as possible. And then finally, I said to myself, hey, you know what? I'm going to use Blazor for UI because I just love it. So with Rust, how many of you have heard or used Rust? Show of hands? No? Okay, a couple of people. Well, it's a systems programming language. If you use C++ in the past, you will see that it's actually quite close to it. It hasn't derived from it, but it is actually very close, and it is the closest code we can run to the bare metal. And it is quite fast. Probably the most important thing is the memory safety. Because what happens is C++ relies on manual memory management, but Rust relies on it has no garbage collector, and it relies on smart pointers. And what smart pointers does is as soon as something is not needed anymore, it just basically gets rid of that pointer. And then, as I said, I wanted to use Python because that is the AI language. How many of you are using Python? Oh, good. We have a lot of people here. Cool. Well, Python, I chose Python because it's easy to use. It has a large community support, and it has a lot of simplicity. And with that simplicity, even though it's simple, it still has a lot of power. And with Python, even though as language, us .NET developers may look at it and say, this is scripting language, the power of Python is on the libraries that it uses. All of its libraries that are used for data science and machine language are actually developed in Rust, the language I just showed you. And because of that, they're extremely performant. And because of that, they're very, very good. And they have a very rich ecosystem, which we will see. We will make use of them. And then AutoGen, when I asked the question, and I said, okay, multiple agents, they're just going to talk to each other. They can scale independently. They can collaborate independently. It's actually pretty cool to see. Unless I'm assuming everybody here is .NET developer in one way or another, and so we know Blazor. I wanted to use Blazor. I like Blazor WASM though, not the server side, so it's just easy to use for me instead of dealing with JavaScript and whatnot. I just write everything in C#. This talk and this project is based on a blog article that I have written a couple of weeks ago. But we are going to add some little nuances to it, right? If you want to look at that blog, you can see. So who am I? My name is TJ Gokken. I'm an AI ML integration engineer, which means that I integrate artificial intelligence or machine language solutions into existing applications. So, and I blog at tjgokken.com. Now, all the code that you're going to see tonight, I've actually prepared beforehand. I'm not going to do live coding. And there's a reason for that.
So we can just daisy chain up to 127 USB devices here. That's an everyday task. Let's plug it in. It's going to say, hey, I see, again, a new device. And it's going to load in the appropriate drivers. You'll notice that this scanner builds load.
I basically does not want this to happen to me, right? Because when that happens, you have to be like this in the presentation. But you feel like this inside. Pure rage, nothing else. So I don't want this to happen to me. So we're going to go and look at this code that I've already compiled, tested, and hopefully it'll run. So we'll see. All right, let's get on to our coding right now. So as I said, we have basically 3 parts to our code. Rust, Python called AutoGen, and then Blazor to show the results of what's been happening. So if you look at Rust code, and I realize that most of you are not familiar with Rust code, but this is basically what it looks like, and it's just getting system information. These structs are the same as our properties, data models, basically in C#, right? And it just basically just goes, iterates over the computer CPUs and disks and collects that information. It's just basic boilerplate stuff. So when we run this, this is what we get. It generates an executable, and it collects all the information about my CPUs, disks, my memory, and whatnot. And that's all it does, and that's all I want it to do, right? Get the system's information and give it to me. Once that happens, then we will have our Python code. Now, a lot of you I see here are familiar with the Python code. What happens is here we're using something called Flask, and that just gives us API endpoints for our Python code, right? It's very easy. It's basically the same as ASP.NET Core Web API, but with a lot less overhead, and we can just do this in a couple of lines, really, and you'll see that. So we basically call our system diagnostics orchestrator, and there is this code. Basically what it does is it runs the executable, the Rust executable, and then it gets that data, because I just shown you that in command line, the Rust executable produces a JSON. So it just reads that JSON output, and then just gets that JSON output and calls AutoGen. And look, this is how it calls AutoGen. This is the system information, and this one calls the system collect info, and then analyze its matrix, memory, storage, just stores it in its own data models, and then basically just chat result calls the AutoGen. And this is all there is to it. There is just one line, as you can see. And that's where AutoGen's power relies, because everything else is handled by AutoGen for us. Multiple chats, the agents chatting with each other, and then collaborating, coming up with better results, better solutions, and everything else. Let's see this in action. So I'm going to go and run this. And once I run it, as you can see, it says, hey, this is a development server. It just gives up that warning. And it tells me which IP addresses I can run this on. So let's go and visit that IP. There you go. It's working. That's Flask just giving us the API. Can you see it easily? Better? And it just says, hey, use recommendations. I could have just kept it at that, but I'm thinking that, hey, we can actually make this a bit more capable in the future. So let's add the recommendations to it. And then we get our result in JSON. As you can see, it got everything from Rust, and then on top of it, it has the optimizations. And these are the AutoGen talking to each other. So this is very cool, because let's look at this now. Remember, it was up to here, our code. Once I ran this recommendations and I hit that API, then the agents just got, hey, these are my prompts. Please analyze these system metrics, blah, 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 right? And I give them the system metrics. And then, as you can see, they started talking. There's a user proxy that manages all this talk between the agents, so it acts as the mediator. And hardware expert goes, hey, to analyze hardware specifications, blah, blah, blah. And it's basically telling what can be improved and what are the upgrade recommendations and all that. And then next, the software expert comes in. And it says, hey, based on the software that I get from this system info, this is what I tell you to do. So this is how we can optimize our system. And then, as you can see, software expert then says, it doesn't just give to the next agent. And it just says, hey, if you provide specific hardware metrics or performance data, I can further refine my recommendations and whatnot. This is all happening automatically. I'm not doing anything. I just had that one call. That calls AutoGen. And obviously, I set up the agents and whatnot. Can you see easily? Yeah. And again, the software expert, they basically just talk to each other, and software expert says, I give you these recommendations. Now, let's get these recommendations into our Blazor application. So to get these recommendations, again, we read the JSON from Python itself, and we hit the Python on this URL address that I just showed, because that's where everything is from Python. And once we get them, we have to put them into our own models. And that's why we are actually mapping the JSON properties to our properties. Otherwise, you will get an error. And once you do that, all you have to do is just run this. So let's hit our Blazor. Where is the Blazor? Didn't I tell you something always goes wrong? So let's run this again. Aha! I think I know. No, it's not. Well, the result is... Let's get this from the launch settings. And of course, it's not running. You gotta love this, guys. Okay, let's try this again. Let's run this here. Sorry, I gotta choose this. Thank you. Okay, it just decided not to do anything about this. So let's try the other ones. Okay, obviously this is not working as it was just 10 minutes ago. So it does actually just take these recommendations and puts them into a very nice user interface. And I actually, I can try to debug and see what happens. Launch and all this stuff is ready. Okay, hey, didn't work. Not sure why at this point. But what is it?
If you're having connection issues,
no, I don't think it's a connection issue because it shouldn't have any connection issues.
Yeah,
it just
check that you're connected if you're online. And then...
No, I'm online because it gets the information. Gets the recommendations. Okay. Otherwise, you wouldn't get them.
So it's part of it.
Yeah. So for some reason, it just says, you know what? Because it's a live show, I'm just not gonna work. Happens sometimes. Okay. Well, let's see. Let's hope that we do better at the next one, and I can at least show you how this code is working. Well, what it does is it actually puts it into some nicer interface and just puts into graphics and tells you the recommendations. It basically just formats the JSON code. I'm not sure why it didn't work. It may be the setup or, although I don't think so because I did test it just about 15 minutes ago. Well, moving on. So what happens here though, is we first compile the Rust code, then we have to copy Rust executable to Python folder. That's important because Python needs to call the Rust executable. And after that, we run the Python code, but we run actually the Flask server, so the APIs are available to us. And then we run our Blazor code, and Blazor actually calls Python, and Python executes the right Rust binary again to get that information for you. So, and every time we make a change, like if you make a change in Rust binary, we have to compile it, copy this file into the Python folder, and restart everything again. And that is a very cumbersome process, way of doing things. So I thought, hey, I do not want to do this all the time. Is there a way to automate this? And then I thought of Microsoft Aspire. Do you guys know Aspire? Yep. Aspire is basically an orchestration framework. So what we're going to do is we're going to tell Aspire, instead of us compiling this Rust binary and then copying it and then running Python and whatnot, we're going to tell Aspire to basically manage everything for us, fire these things up, and have the website ready for us, and then we can just consume this. So let's see, and hope that it works this time. For this to happen, I will just need to make this. And I'll show you this. Basically, we're telling Aspire, this is an Aspire application, and we're telling, hey, build the Rust project first. We call it system info collector. We give them the path and whatnot, and we're using a command called cargo. Cargo is basically the equivalent of .NET command. In Rust, it just runs the code and compiles it. And after that, we copy this binary to Python's folder, and then we execute the Python. But before we do that, the ones that you are familiar with Python, we also make sure that we install the requirements in Python. Because if we don't, then it may not run for us, right? And then we add the Blazor UI, and we just run it. So let's see if this will work this time. As you can see, Aspire tells us, hey, there's a lot of things going on, but it finished some of the processes that it was doing, some of the tasks, and the others are running. It looks healthy to us. So we try to get to this site now, and now we have our hardware assistant, HAL application, and it's basically gotten everything from Rust, and it has put those system information into this nice graphics for us. But more importantly, AutoGen agents gave us the recommendations, what to do, what not to do, and how we can improve the system, and it's giving us all that too. Now, what I need to show you is this. When I run Aspire, I get a lot of warnings and failures. Even though everything is working, I get these failures. The reason I found that is Rust, for some reason, does not work well with these. They actually conflict, right? So if I have this Blazor application and I want Rust to run that, I don't like seeing those errors because, first of all, any kind of errors or warnings that I see is a potential bug down the line. So I don't want to see them. So what I'm going to do is I'm just going to rename this. So there are no launch settings in my Blazor application. What happens is, because Aspire is orchestrating everything, Aspire is determined the launch settings for my Blazor application. It's actually quite cool. So let's run this again. And we click on it, and there you go. We have our website. So what happened to our errors? Can you see this easily? Sorry. Unfortunately, I have to do this every time. If anybody knows how to do this once, and no, it didn't work. Okay, this one will. So what happens is I do not have those errors anymore. as you can see, because the launch settings are not conflicting each other. But what happens is I still have a fail. It says, hey, this one open process, the parameter is incorrect. The reason why this is happening, even though everything is running perfectly, is because you see these two, copy binary and system info collector, they're finished. Even though these processes are finished, these tasks are finished, Aspire still tries to monitor them. But because the tasks are finished, they're not there anymore. So Aspire is telling me that, hey, I cannot find this PID, process ID. So I don't know what to do about this, even though everything runs perfectly because Aspire did do what I told them to do. There's a way to get around this, and I'm going to show it to you. But if we do that, we will lose some of the functionality that we were going for. So let's go back to our Aspire code, to our program. I am going to get rid of all this code, comment it out. And then uncomment this one. What I did is code is basically the same. I just changed the way I told Aspire to run the Rust code and copy the binary. So I'm now using my process start info class in C#. But what does this do? I do not have the error anymore, right? Everything is running perfectly. But I cannot see or monitor the other tasks anymore either. So I don't know how my compilation went, if there were any errors or not. And I don't know how my copying of the binary went, if there were any errors or not, which kind of negates the use of Aspire, because one of the things that I like about Aspire a lot is because I can monitor all of my tasks, all of my services, and see how healthy they are or if there are any issues. I looked for in Aspire to overcome this. I was hoping that there is something like do not monitor after completion or some method like this. Unfortunately, I couldn't find anything in the documentation. So since Adam's here, if you can relay that to the Aspire team, that will be great. I think we need something like this for this kind of processes. But it'll still run as it will, as I have shown you. So going back to this, now let's stop it. And I want to show you one more thing. If I run this, in my sequence of events in Aspire, when I was telling it, I actually tell Aspire to compile the binary first, Rust binary, copy Rust binary to Python folder, run Python Flask API server, the Python application, and then last run Blazor, right? But here, as you can see, I do not have that order. So here it looks like, hey, it first copied the binary, then ran Python, then ran system info collector, and then lastly it ran Blazor UI. The reason why this happens, if you see this, is because Aspire actually fills this table up, shows you this table according to when it starts executing these processes. So I want to overcome this though. I do not like this because it kind of confuses me. What if I had 20 different processes or tasks here and I couldn't see what was happening? I want to see this. So the way I came up with this, and I'm not sure if this is the right way to do it, but it works. So I'm just going to put A And I put it in the wrong way. You cannot put 1, 2, 3, by the way. Aspire complains. It needs to be a letter. I forgot something. And then when I run, that should show up in the correct order, as you can see. Now Aspire shows everything that I ran in sequence, in the correct sequence. And that's what I want. I do not want things all over the place. And if I run the application, I see that everything is running fine, and I get some recommendations from multiple agents. So instead of AutoGen, we could have used other libraries called Crew or LangChain or even Microsoft semantic kernel. The reason I use AutoGen is because AutoGen actually takes care of this multiple communication, multiple agents firing up and talking to each other automatically. As I've shown you in the Python code, you only need a one-liner. That's it. You say, hey, start chat after you set up your agents with the correct prompts. And my agents were basically software expert, hardware expert, and all that. And I say, hey, talk to each other and give me some recommendations based on these information that I have from my Rust binary. And that's what they did. So that was quite cool. And as I said, the one for me that the best one is that how they talk to each other. Here, hardware expert talks to the software expert, and then software expert talks again. Software expert seems to be a bit more chatty than the hardware expert. But I just like that interaction. If you have multiple monitors, which I cannot show you here, once you run the code, it's actually, you can see they're talking to each other one by one. But it does happen quite fast. So with all that running, what challenges did I run into? Well, cross-language integration and documenting this. I've never seen an example of being this done before. So that was quite challenging. How do I do everything? I use different IDEs. As you can see, for Rust code, I use C Lion from JetBrains. For Python code, I use PyCharm, again, from JetBrains. I could have used VS Code, but I'm one of those guys, for just some reason, just couldn't make my peace with VS Code. And then for Blazor, I used Visual Studio, obviously. But it was quite hard to figure out how they're going to run. And then with Aspire, I ran into other challenges too. How do I orchestrate this? How do they talk to each other? With the Aspire code, for example, there is a command, wait for completion. I'll actually show you this because it's quite cool. Right? Rust build, binary copy, but it says, hey, before you copy this binary, wait for completion of the compilation of the Rust binary. And again, only run Python after you copy the binary. Do not run before, otherwise it's just going to fire up all at once, and it happens very, very fast. And then here it says, I'm not going to wait for completion of Python because they can run in parallel. I'm just basically going to say, hey, wait for Python. But I could have said wait for completion too, but that doesn't work. The reason is Python task is not a task that completes. It just runs, and it makes the APIs available, and that's it. So if you say wait for completion, you will see that you'll never get there, right? This will just basically wait. See? Blazor is waiting for Python to complete, because basically Python is never going to complete because it's just running the Flask server. So that was one of the complexities, and using different IDEs obviously does not make this any easier. I tried to get everything. I have a confession to make. I tried to get everything into Visual Studio. Turns out Visual Studio is not that great with Python or Rust. There is an extension called Rust Analyzer, and you can add that to your Visual Studio, and then you can actually run Rust code. However, there are no templates for it. You have to add a text file and rename it to .rs for Rust extension, and then write Rust code in it. IntelliSense works, but to me, that's a bit cumbersome, and that's why I went the sea lion way. And the next challenge was AutoGen configuration. What happened is setting up the agents required a bit of thinking, because you need to set them up with specific prompts and specific things. So you, just with anything, anytime we talk to ChatGPT or Cloud or any AI chat program, chatbot, it takes us a couple of iterations for us to get this prompt ready or get this prompt right. It's the same for this. It took me a few iterations to get the prompts right. They hallucinated, and they came up with funny stuff too in a couple of the earlier prompts. And obviously, in the code, if you look at the code, which will be available on GitHub tomorrow, we are using ChatGPT 3.5 Turbo. You can use other models. I just did that because it's cheaper. So handling API and its costs also became important too. And I told you about, with the Aspire configuration, the endpoint conflicts. If you have the local host, the endpoints conflict with Aspire. I couldn't solve that. I just couldn't get to the only way I could do it was get rid of the local host launch settings in the Blazor application. And also port management is very critical. If you say, hey, Python is on port 5000, but you say Aspire, hey, go to Python, or Blazor, go to Python, and it's going to be on 5001, obviously it's not going to work. So you have to make sure that in an application like this, everybody is on the same page and it's doing the same port management. Now, this is more of an issue when you're running the manual application, like I did at the beginning, which the Blazor refused to work. But with Aspire, it's a bit easier because Aspire can control the ports and all that. So before we go into that, I just want to talk about a real-world example. Okay, I did a system information. We collected my system and all that stuff, but it's all local, right? How can we apply this to the real world? Well, chances are, in the real world, you do not have to write all three codes. They will be given to you. So let's say if it's an inventory management system, you just you're given Rust code for data collection, maybe from sensors and whatnot. And sorry, I touched it. And then you're given Python for AI ML analysis. And then you can write your Blazor code and you can integrate everything together and use Aspire to orchestrate instead of manually running it. With Aspire, instead of Aspire, everything I've done with Aspire, you can easily do it with PowerShell or another script and whatnot. However, I like the fact that Aspire provides you with a dashboard that you can see if something is going wrong or not. And you can check the health status of your tasks. So do you guys have any questions? It was either really good or really bad. So any part of the application you want me to explain again or go through maybe more in detail about code or? Yes. Yeah, with the Python code, what we run is, get rid of this. Basically, the system diagnostics orchestrator is the one that does. And at the end, we're just basically telling Python to listen on all ports, to display itself on all ports, right? But sorry, all addresses and port 5000. So if you look at the orchestrator, these are just the setups. You see, I'm using GPT 3.5 Turbo, and there is a user proxy agent, and this user proxy agent is the one that manages the communication between agents. And we go basically with the user proxy agent. We say you're the coordinator, and then we say hardware expert. Hey, you are the hardware expert. You can see the prompt here. Is this readable? Can you guys read it easily? Okay. And then there is a software expert. So I have two experts here and user proxy agent. I can easily add a network expert and say, hey, you're the guy who is responsible for network stuff. I can get from Rust, I can get security information, right? Which ports are open, which ports are not open, and all that stuff. And maybe I can pass that to another expert that I create. Let's call it security expert and whatnot. So basically, this is really cool stuff, and they will just talk to each other. And then, as I said, we just basically initialize the group chat, and we just limit the maximum round of chats to 5. And this is just prompt stuff, right? And this is what you ask for, I think. Collect system information code. This basically calls the the Rust executable. There's a Rust executable path. It just goes and runs it, and that's it. But as I said, for this to work, Rust executable has to be in Python's root folder. Otherwise, we can pass the path, obviously, right? But I ran into some security issues with that. So easiest way was to just copy the binary to Python's root folder. I do this manually at the beginning, but later on, Aspire took care of that for me. And then you extract the recommendations, and you do some calculations. So we can, there are some calculations of code there, so we can display, instead of like billions of bytes, we display in gigabytes and all that stuff. And after that, we just make it available as our system structs. Our structs, the data models, and as JSON. That's it. Yes.
It's amazing to see the agents that talk to each other. I'm interested to see, are you able to see the token usage, how much they use to talk to each other?
That's a good question. Sorry, the question was, how can we see, or did I look into token usage of the agents? That's a good question, and I did not. I'll take that into recommendation. I'll put an update by the weekend, by Friday, and I'll put that into Blazor too, Blazor UI. So if you give me your, if you just look at the video when it's available, I'll put it as a comment there. Or if you can give me your information, I can send it to you too. But I can at least tell you, hey, it's ready now. But yeah, that's an interesting thing. But I'm using GPT 3.5 Turbo, which is kind of in the AI world ancient, right? It's kind of like 2000 BC, and so I'm thinking it will be very little, or probably free or cheap. One thing I want to do to this presentation is actually upgrade it to use local LLM. So we don't go out to ChatGPT at all, which means that everything will be free.
You're paying for API calls each
No, the agent talk is done within AutoGen itself. So it's one API call as far as I know. So they just talk to each other, but they give it back to you. And chat proxy agent is basically saying, okay, next, okay, next, okay, next. And just AutoGen gives that information in Mongo to you, from what I can see. Well, let's actually run it again. Let's see that in action. Why not, right? I really like watching this stuff. That's we'll do this here. Cool. I'm still running this, so let's clear this. I'm just going to run it from here. Okay, so now our server is running, Python application. Let's close this. And let's hit this. I need this as well. Sorry. Too many stuff. Open. Okay, let's hit this again, and we'll see that it's just gonna. It happens fast. I should put a delay on it. So what happened? It says, hey, please analyze these metrics. It happens very, very fast. So that just basically tells me, because there is no network lag, AutoGen does everything in Mongo and just spits it out to me. Please analyze these system metrics and provide specific recommendations. And it gives my system information. And it says, hey, please provide critical issues, performance recommendations, optimization opportunities, and upgrade recommendations. And then they look at it. Hardware expert goes, whatever CPU performance issues, monitor CPU usage with, these commands and whatnot. And then the software guy takes over, and it says, hey, you should do this. Obviously, this is a very basic sample or example. We can actually make this as detailed as possible. Hardware upgrades. Based on the analysis, consider upgrading the CPU. Memory or storage components. Yeah, that's a great recommendation. Evaluate this and all that stuff. Implement RAID configurations for improved performance and data redundancy and all that stuff. But it just gives me this information back, because the agents just talk to each other, really. And as you can see, how they all of a sudden they just talk to each other, and we see it. And I was going to show you this too. It all depends on how you set up the agent, right? So, hey, this is the hardware expert. This is the software expert. Really, this part of the Python code is the brain of the whole operation, because this does it. And then it calls, and it says, hey, this is your manager. And basically, then it says, get the recommendations. That's all it does, really, here at the end. Not the system info. Process diagnostics. As you can see, it says these, and diagnostic prompt. Create analysis prompt and initiate chat. And then that's it. It's not saying, hey, hardware expert talk, you talk first. Software expert, you talk second. And then you guys chat and all that stuff. It just basically say, initialize chat and give me the recommendations. And AutoGen, the framework itself, does this for you.
kind of reminds me of that. Do you think something like this could be used to allow the AI to look at the data set in a way that's kind of impartial?
I actually think it can. The question is, do you think something like this can be used for AI to look at a data set? And what was the other?
In a way that's kind of more objective and impartial because it's coming from multiple different perspectives.
So it can be objective and impartial in its analysis? I think it can. I think it can be used in a lot of ways. For example, they just announced that AutoGen is upgraded to AutoGen is from Microsoft, by the way. AutoGen is upgraded to handle real-time data. So I can. So now we don't have with system info collection. It's static. It becomes static. The information, right? We pass it on, and it gives us recommendations. But now, because of the ability to generate real-time agents and real-time recommendations, we can actually get real-time information on something that changes, let's say stock market or whatever. To come back to your question, I think yes, it can be used for that reason. You can set up different agents, and they can talk to each other. And you can actually set one agent to be the ethical guy and the one that makes sure all the other agents are impartial and objective. And it just basically controls them, or not controls them, but checks them basically. They say if they go off tangent, it can say, hey guys, what are you doing? Come back to Earth, hopefully. But I think that it's going to go there. And I actually think this can be also used in code reviews. You can set up multiple agents, and they can look at your code review. You can review. They can review your code. Sorry, because you don't have one agent looking at your code anymore. You can have a C# expert and .NET expert and database expert and and whatnot, API expert, all of them, and they can look. And one of them could be just the optimizer. Does nothing but optimization and all that, and you can actually set them up and say, hey, look at this code. I actually thought of doing a Visual Studio extension like that, but so far I haven't been successful. But I think it can be used in that way.
I mean, I thought the second idea really sounds like it would make code review.
I mean, I find the second idea really interesting that you were mentioning about code reviews. I think it could make the process a lot easier because it's taking a lot of the burden off of seniors to kind of go in and look at micro optimizations that juniors might not be concerned with.
Yeah, I agree. The comment was basically the second idea was very interesting, and it can release the burden on the senior developers and all that. And I agree, it can. And I think it's going to go there, whether we like it or not. The important thing is to watch for hallucinations and all that stuff. Because as much as capable as they are, they still hallucinate a lot. And my earlier prompts, when I couldn't get them right, they were actually giving me recommendations that I don't even have that hardware, issue or that configuration. It was saying, hey, you only have 8 gigabytes of RAM. You should, consider upgrading. I'm like, what are you talking about? I have like 4 or 5 times of that. But if you don't set it up, so you have to be precise, as you know, with any AI prompt. If you're precise and if you tell them exactly what its role is, they're quite capable. Well, that's the case. Then this is the user group feedback link. If you can just give me some feedback and we can improve. One of the things I have is actually make sure the Blazor code runs in the first section, and that's about it. So thank you. Okay, now are we not live anymore? Are we done?
If anyone's got more questions?
Yeah. No? Okay, done.